Now the next topic is Pythagoras theorem. Now first of all, I'll come to Pythagoras theorem, but to prove Pythagoras theorem we need another theorem that says if a perpendicular is drawn from the vertex of a right angled of a right angled triangle to the hypotenuse, then the triangles on the both sides of the perpendicular are similar to the whole triangle and to each other. Now I'll just explain this to you by a figure. First of all, if we have a right angled triangle, let's imagine that we have a right angled triangle over here, ABC. Now if a perpendicular is drawn from the right angled vertex to the hypotenuse, this is the hypotenuse, this is the right angled vertex, correct? Now if a perpendicular is drawn from this vertex onto the hypotenuse, then this triangle is similar to this triangle, and this triangle is also similar to the whole triangle, and this obviously this triangle is also similar to the whole triangle. So this is what this theorem says. If a perpendicular is drawn from the vertex of a right angle the right angle triangle, from the right angle of a right angle triangle to the hypotenuse, then the triangle on both sides of the perpendicular, this is a perpendicular, correct, on both sides of the perpendicular are similar to the whole triangle and to each other. Okay, so this is what this theorem says. Now we will use this theorem to prove the Pythagoras theorem. Now what does the Pythagoras theorem say? In a right triangle, the square of the hypotenuse is equal to the sum of the square of the other two sides. Now let's come to that. First of all, what we have over here is, look at this figure. In this figure, in triangle ABC, angle B is the right angle. Now what do we have? In triangle ABC, angle B is the right angle. Okay, so AC is the hypotenuse, correct? Now the square of the hypotenuse is equal to the sum of the square of the other two sides. Now what do we need to prove? To prove that AC square, that is the square of the hypotenuse, is equal to the sum of the square of the other two sides. So sum of the square of AB and BC. So AC square is equal to AB square plus BC square. AC square is equal to AB square plus BC square. This is what we need to prove. Okay. Now coming on to the proof. First of all, we do a construction. What do we do is, we construct a perpendicular from B to AC. Now if you see over here, what happens in this is, according to this theorem, if we draw a perpendicular from the right angle onto the hypotenuse, then the triangles on both sides are similar to each other and to the whole triangle, correct? So from here, what do we get is that triangle ABD is similar to triangle ABD is similar to triangle ACB. Did I write it correct? Triangle ABD is similar to the whole triangle. First of all, we know that, right? Now which angle is equal to angle A? Angle A is equal to angle A, right? Those are common in this triangle, the smaller one ABD and triangle ABC. We have to determine which angles are equal, and that is how we write the sequence of the similarity in the similarity, correct? So angle A is common with angle A, correct? Right? Those are both of them are equal. Now angle, if we see over here in triangle ABD, angle B angle B is equal to angle C and angle D over here, this is 90 degree and angle B over here is 90 degree. So D should be with B and B should be with C. So triangle ABD is similar to triangle ACB. Both all these are corresponding angles and corresponding sides written in the correct sequence, correct? Now this, where did this come from? This came from this theorem, correct? Now we have triangle ABD is similar to triangle ACB. Now what do we get from here is the sides are also in the corresponding sides are also in same ratio. So AD upon AB is equal to AB upon AC. AD upon AB is equal to AB upon AC, correct? Now from here what do we get is AD into AC is equal to AB square, correct? Let's mark this as 1. Okay. Now we also know that triangle, let's say BDC is similar to triangle ABC, we have to write, correct? Now let's see what sequence should be written in. Angle C is common, so C should come in the last. Angle D is 90 degree, correct? So which is 90 degree in this? B, correct? So B should come over here, and at the place of B we have to write angle BDC. BDC is similar to triangle ABC. Now see over here, have I written the corresponding sides and the angles correct? Angle B is equal to angle A, angle D is equal to angle B, and angle C are common, correct? Same way as I wrote this, this is also written the same way. So from here what do we get is the ratio of the corresponding sides is again equal. So what do we write from here is that CD upon BC. We have CD upon BC, okay, is equal to BC upon BC upon DC, correct? Sorry, BC upon AC. BC is from that. BC upon AC. So this is what we get, that CD upon BC is equal to BC upon AC. Yes, we have CD upon BC, okay, is equal to BC upon AC from here. Yes, it is correct. So this is what we get from here. Now from here what do we get is CD into AC is equal to BC square. Let's name this as 2, correct? Now what do I do from here is I add 1 and 2. Adding 1 and 2. What do we get is AD into AC plus CD into AC is equal to AB square plus BC square, correct? Now if you see over here in these two, AC is common, correct? So we have AC into AD plus CD is equal to AB square plus BC square. Now tell me one thing, what is AD plus CD? AD plus CD is equal to AC, correct? So we have AC into, let's replace AD plus CD by AC is equal to AB square plus BC square, and this says AC square is equal to AB square plus BC square, and this is what we needed to prove. AC square is equal to AB square plus BC square. So Pythagoras theorem is the square of the hypotenuse is equal to the sum of the squares of the other two sides, and we've just proven it.